Hello, 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 everybody, and welcome back. We're looking at the 2012 open paper, and we are going to be starting part B of the contest with, of course, B1. Alice and Bob run in a clockwise direction around a circular track. So they both run in the same direction around the track. Okay. Each running at a constant speed. Alice can complete a lap in t seconds, and Bob can complete a lap in 60 seconds. They start at diametrically opposite points. So it's half the total lap distance, which, I don't know, let's finish reading the question. When they meet for the first time, Alice has completed exactly 30 laps. Determine all possible values of t. So they never actually tell us the lap distance, but if we said, it's L, or if it's C for circumference, I'm going to go with C for circumference. So the length of the lap, or the length of the track is C. So Bob comes a C over 2 before he's where Alice is originally. Okay, and then when they meet for the first time, Alice has completed exactly 30 laps. So she's gone around and around and around 30 times, and she's back here. She and Bob meet for the first time. Okay, and I think that first time is going to be key. Otherwise, there could be lots, probably infinitely many values of t. So Bob needs to go C over 2 and then needs to go around a certain number of times. So you might say something like Alice travels 30C, Bob travels. He's got to do the C over 2 to get to where Alice's starting point is, and then complete an integer number of laps. So I guess 2k plus 1 over 2c. Okay. So those are the distances, in case we need them. But what else? Well, they're meeting for the first time, which means they don't meet at an earlier point, and I think that forces certain things. That means every time they go around, they don't meet, but they must be getting closer, because after 30 laps, they finally sort of sync up or hook up or meet at the same point. So what would it look like to Alice as she goes around? Alice moves at a constant speed. She doesn't move at Bob's speed, otherwise they'd always stay opposite each other. So she moves a little faster. Then by the time she completes one lap, where would Bob be? Well, if she's faster, Bob hasn't quite completed a lap. He'd be about here. Okay? And as she goes again, Bob, in her view, Bob is sort of slowly moving backwards relative to her. Of course, if she's slower than Bob, Bob will slowly be catching up, and this is what she would see each time she completes a lap. So there's probably, I would say, exactly two answers, one where Alice is faster, one where Alice is slower, but I don't think there's going to be any more than just those two answers, because they have to meet for the first time at the 30th lap. So if, for example, I were to say, just very, very quickly, sketch the distances that they go. If we imagine sort of Bob's, if we got time here, Bob's speed graph looks a little something like this, and then Alice's looks a little something like, well, might be something like this, or she might be faster, but it's a constant speed. So they're all going to be lines going through the origin. Let's say this is Bob. And then we've got actually, let's make that Alice. So we'll say Alice, and we've got a nice fixed point. At 30t, after 30t seconds, Alice has completed 30c. Okay? And Bob will, at 30t, he should be at the same point. So he is up or down an odd number of, Bob is at 2k plus 1 over 2c. That's how far Bob has gone, which is going to be, I guess, kc plus a half c. But the point is, the difference between Alice and Bob is going to be some half multiple of c. So the difference in their overall distance traveled should be 30 minus k c, an integer amount of c, plus a c over 2. So it could be something like, well, the difference between them is just a half. Bob has gone a half a lap more or a half a lap less than Alice, and they've hooked up. They've met at the same point. But it could be that maybe Alice is just that much faster, and Bob has gone some laps, but he's still sort of 3c over 2. He's gone a total distance 3c over 2 less than Alice. Okay, now that would still mean that they are at the same point. Anytime their total distance traveled differs by an odd over 2 multiple of c, they will be at the same point. They won't necessarily be at Alice's starting point, but they will be at the same point, because that means Bob has made up the half lap distance between them, plus maybe more or less some integer values of c. But going extra laps around doesn't change his overall position. Okay? So this is why I don't think we can do 3c over 2. And then, so the difference between Alice and Bob's total distance traveled has to be c over 2, because if it were 3c over 2, then we could, using similar triangles, find an earlier point where they were c over 2 distance away from each other. And at that point around the circle, maybe Alice isn't right at her starting point, but maybe she's here, but Bob has made the c over 2 distance between them and then managed to catch up as well. Okay? So, all this reasoning, which for some of you might be obvious, some of you might not even thought of this, some of you might just be saying, well, obviously there's two answers. Well, I would say no, it's not always obvious that there are two answers. And while we don't have to show our reasoning because it's a Part B question, it's still important to be able to realize, why are you only going to have two possible solutions? It's because of this first meet complication. That the first time they meet, they'll always be c over 2. The difference in their total distances will be c over 2. And so if the first time they meet is after 30t, after Alice has done 30 laps, then the distance between Bob and Alice, either if Bob is slower or faster, must be c over 2. Okay. So with that in mind, what can we say? Well, I doubt their solution goes into this much detail. They probably just assume you can reason. And they would give you the marks. You don't have to draw a distance graph or anything like this. They will probably just accept that, yeah, there's only going to be two because of the first meeting. But why is that exactly? Well, you should be able to reason it out for yourself, even if you don't have to reason it out on the contest. So the first time meeting implies Bob has only traveled c over 2 more or less than Alice. Okay. So, Alice has gone 30c. And Bob has gone 30c plus or minus c over 2. Okay. But they've done this in the same time. So, let's say 30t equals the time, but that also must be the same as, well, how long has Bob been traveling? Well, 30 for each lap he goes, plus or minus this half lap that he must do. So this is 30 times 60 plus or minus 1. Divide by 30 on both sides. T is going to be 60 plus or minus 1. So T is 59 seconds or 61 seconds. And there we go. Alice is just a little faster or a little slower at completing the laps, but even though you could say, well, if she were slower, you might be able to meet up at 57 seconds. If she does a lap in 57 seconds, they might meet up. But it's about that first meeting happening after 30 laps that makes this all work out. And that's why you're only going to have 2 answers. And there we go. So that's B1. Up next, of course, will be B2 and so on. So I will see you for that in the next video. Until then, take care.